Hello everyone, hope you are doing extremely well. Here in this video, I'm going to solve another problem from DSA sheet and array section. It is three-way partitioning. Let's get started. Here it is saying that we will be given an array of size n like this, and we will be given a range AB. We will given two more values A and B, and we have to divide this array into three parts such that all the elements smaller than A must come before A, and all the elements in the range AB must come between AB, and all the elements greater than B must appear at the end. And in individual sets, elements can appear in any order, and we have to modify the array and return it. If our output, if our modified array is correct, then generated output will be 1. And here the first approach which comes into my mind is sorting. What if I sort this array? When I sort this array, automatically all the elements will be arranged in ascending order, in increasing order, and here there will be two values A and B. Automatically after they have arranged, all the elements have arranged, the values which are smaller than A will come before it, and values which are larger than B will come after B, and rest of the values will come in between A and B. So automatically a given array will be modified, and we are going to return that array. But the time complexity here will be big O of and log n for sorting. Can we do it in a better way? Yes, of course. We can do it in big O of n. Let's find out how we are going to do it in big O of n time complexity. Let's understand it with an example. Let me take two values as A and B, that is 44 as A and 62 as B, and let the given array be 76, then 8, then 75, then 22, then 59, 96, 30, 38, and 36. In this approach, I'm going to traverse this array only once, so our time complexity is going to be big O of n, and I'm going to scan each element, and if it is smaller than 44, then I will send it at starting, and if it is greater than 62, then I'm going to send it at the end. And after that, if I find another value that is smaller than 44, then I will send it at the next index from the starting. And similarly, if I found the next value which is larger than 62, I will send it in at the index just before the ending index. For doing this, I am going to place two pointers which will always point to a position at which next smaller or larger value should come. This is our starting pointer and this is our ending pointer. So the values that are smaller than 44 will come at this index at any point of time, and similarly the values that are greater than 62 will come at this index at any point of time. So initially, I'm going to start scanning from here. For that purpose, I'm taking variable I. I will scan this. I will compare it with 44 and 62. I will compare it. Is it less than 44? No, it is not. Is it greater than 62? Yes. As it is greater than 62, then I need to send it at the end. So we will swap it with whatever value is placed at ending index. 36 will get swapped with 76. 36 will come here and 76 will go there. 36 and 76. As this is the correct value, this is the value larger than 62, it must come at the end. It has been placed at the end. So the next value, larger value, then 62 should be placed at its previous index. So I have moved my ending pointer one place ahead, and I will not change my starting and I. I'm not changing starting because I'm not placed any value that is less than 44. I will not change I because this value that has come from the end has not yet been processed. I have not checked it whether it is less than 44 or greater than 62. Now I will check it. Is it less than 44? Yes. Then I will send it at the first position. I will swap it with itself. So no change will occur, and then I'm going to increase my s as next smaller value should come here, and I will increase I that I have processed it. Now I will check for this value 8. Similarly, as it is less than 44, it will get swapped with itself, and I will increase here both s and I. As 75 is not less than 44, it is greater than 75. I will send it at the end, and I will swap it with 38. 38 will come here, 38, and 75 will go there. As I have swapped it with ending index, I am going to move ending index one place ahead, and I will not change my s and I. Now ending index is pointing to 30. So I will check again for this value which has come from end. Is it less than 44? Yes, it is. Now I will move my both values s and I, and as I is pointing to 22. Now I will check for 22. Is it less than 44? Yes, it is. Now again I'm going to move s and I to this value. Is it less than 44? No. Is it greater than 62, 59? No, it is not. Then it must come in between. In our approach, we will send all the values smaller than 44 at the starting and all the values greater than 62 at the end. And we will not touch the values that are between the range. We will not do anything with that. So as we have found a value that is coming in between the given range, I am going to only increase my I. I am doing this because I am not touching the value that are coming in the range 44 to 62, because they will automatically get at their right position. Now I will compare this 96. Is it less than 44? No. Is it greater than 62? Yes. I will send it at the end. Now 30 will come here and 96 will come here. 96. And I will move my pointer E here. We will not stop. We will stop when I become greater than E, because we know that here all the elements are processed and they are at their right position. So when it go beyond this I go beyond E, then we will stop. We will not stop when I is equal to E, because we have not yet processed this element. We have not yet checked this element that is pointed by E. So here in this condition I is equals to E, but we will not stop. We will check for E. Is it smaller than 44? Yes. Then we will swap it with the value pointed by S. 30 will come here and 59 will come at the place of 30. 30, 59, and S is going to increase. S will point to E and I will also increase. Now I becomes greater than E, means it has come in the segment of array which is already processed, and the elements in this part are checked and placed in their correct order. Now we can stop. So now let's check our array. if it is modified correctly or not. So 44 will come here before 59. 44 will come here somewhere before 59. So all the elements less than 44 must come before it. So these all the elements are less than 44. Okay, all right. And all the elements between 44 and 62. 62 will come here between 59 and 96. And 59 is between them and it is coming in between, and all the elements greater than 62 must come at the end, and at the end all the elements are greater than 62. So it is correct modified array, and if we return this array we will see the correct output, that is 1. So here I have coded it in the same way that I have explained. I have placed here two pointer start and end, and in ln variable I am finding out the length of this given list, and I am running this while loop while I is less than equals to end, that we have seen here. We are not stopping when I is equals to e. We are running one more iteration when I is equals to e, and we will stop when I becomes greater than e. So we will check for each element that is pointed by we will check if it is less than a, if it is in the range between a and b, and if it is greater than b. If it is less than a, then I'm going to swap that value with the value pointed by array start, and I'm going to increase I and start. As we have seen here, at each time we have found a value that is less than 44, we have increased this I and start, because we know that the next smallest value will come at the next index. So we are increasing both, and we are not touching the array elements which are in the range from a to b. So here simply I am skipping them. When I found element that is between this range, I will simply increase my I without performing any operation. And in the case when the value is current value of the array element is beyond the is greater than b, then I'm going to swap that value with array end and decrease my end, as we have discussed here. At when we send each element at the ending, we have to decrease our end pointer, and we will not change I, because we'll again process that element which comes at that position after swapping. So we are not changing I, we are only changing end variable, and at the end we are returning the modified array. So this is the code. Hope you understood the problem. Let's try to run it. Yes, all the test cases will be passed. Yes, it is working absolutely fine. Hope you understood the concept of three-way partitioning, and I'm going to see you in the next video. Till then, keep liking and subscribing my channel. Thank you.